Hi, I'm Ana Sofia Lozada. Today I'm gonna be presenting 3 topics of this first partial of the bimester that are freefall, vertical shot, and conductive and insulating materials. Okay, I'm gonna start explaining freefall. First, what is freefall? Freefall in physics is the state of a body falling under the influence of gravity. This means that the body is accelerating at a constant rate of 9.8 meters divided by seconds squares here on the earth. During freefall, the body is not subject to any forces except gravity, resulting in a motion that is uniform in direction and increasing in speed. Here we have the formulas to calculate the different factors of freefall. For example, height, the final velocity, and the time. We have different formulas for the time depending on what other things that you have. For example, if they give you the final velocity, you do it with the second formula, and if you do it with the height, you do it with the first formula. And in free fall, the final velocity, the initial velocity is always gonna be 0, and we don't have maximum height in free fall. Here are the 3 examples of free fall. The first one is a construction worker accidentally drops a brick from a high scaffold. What is the velocity of the brick after 4 seconds? That's the first one. And B, how far does the brick fall during this time? So we're gonna calculate those two. Okay, so the first thing that we're gonna do is first know that velocity equals gravity multiplied by time. So then we put 9.8 meters divided by seconds squares, that is the gravity, multiplied by the time, that in this case is 4 seconds, and that is equal to 39 meters divided by seconds, and that's the velocity of a second. And then for the question B, we need to know the time, all the time of the 4 seconds. So what we do is that we multiply 39.2 meters divided by square, multiply it by 4 because we have 4 seconds, and that is equal to 156.9 meters, 0.8 meters square. Is those two in the first one. In the second one, a rock is dropped from a garage roof from rest. The roof is 6 meters from the ground, and we need to determine how long it takes the rock to hit the ground and the velocity of the rock as it hits the ground. Okay, so the first thing that we're gonna do is take the time, and the time we know that is the root of 2 times height divided by gravity. Okay, and then that we know that the gravity is 6 meters, so 2 multiplied by 6 meters divided by 9.8 meters square divided by the square second, and inside of the root, and then that's equal to 12 meters divided by 9.8 meters divided by second square inside of the root, and that's equal of the root of 1.22 seconds square. Okay, now we want to take out the root, so without the root is 1.1 seconds only. Okay, now we want to calculate the final velocity, and the formula is gravity multiplied by time, that is 9.9 meters divided by second squared multiplied by 1.1 seconds, and that's equal to 10.78 meters divided by seconds. the rock as it hits the ground. And for the last exercise, we have that a glass is dropped from a building of 8 meters above the ground, and we need to determine the time required for the glass to reach the ground. So again, we use the formula of the time, that is the root of 2 times the height divided by the gravity. Okay, and then we put 2 multiplied by 8 meters, that is the height, divided by 9.8 meters divided by seconds squared, that is the gravity, and then we put it inside of the root, and that's equal to, well, simplified is 16 meters divided by 9.8 meters, meters divided by seconds squared. We divided it and it's the root of 1.6 seconds squared, and that's equal to 1.2 seconds. Okay, vertical shot. We have here the formulas of vertical shot. In here we have everything. We have height, maximum height, initial velocity. The final velocity is always gonna be 0, and the time we have as well 2 formulas for the time, depending if they give you the initial velocity and the height, or if they only give you the initial velocity. Then we have also 2 formulas for the initial velocity if they give you the height, or if they don't give, or if they give you the time. Then, what is a vertical shot? The vertical shot is also known as vertical projectile motion, involves an object being launched directly upward or downwards, and this type of motion, gravity acts as the only force causing the object to accelerate towards the ground or away from it. And here we have the examples of the vertical shot. The first exercise is a projectile is shot upwards at 189 meters divided by seconds, and we need to determine how long will it take for the projectile to hit the ground level. Then we have a tennis ball is thrown straight up to the initial speed at 22.5 meters divided by seconds. It is caught at the same distance above the ground, and we need to calculate how high the ball goes and rises, and how long does the ball remain in the air. Okay, for the first exercise, we need the formula of time for this vertical shot, that is minus initial velocity divided by gravity, and that's equal to minus 189 meters divided by second squared divided by 9.8 meters divided by second squared, and that's 19.28 seconds. Okay, for the second exercise, we need to calculate the maximum height, and the formula is minus final initial velocity squared divided by 2 times gravity, and that is equal to minus 22.5 meters divided by seconds squared divided by 2 plus 9.8 meters divided by second squared. Well, and that's 506.25 meters squared divided by second squared, and that we divided it to 19.6 meters divided by second squared, and then that we divided it, and it is 25 meters. Okay, so for the last one is pretty easy because we know that the time that is up minus the time that it's falling, it's equal to 0. So the result is 0 seconds on the air, like just floating. As last topic, we have conducting and insulative materials. First, what are conductive materials? Conductive materials are substances that allow electric current to flow through them easily. Some examples that we have are silver, that is an excellent conductor of electricity and heat due to its high conductivity and malleability. Then we have copper, that is widely used in electrical wiring for its high conductivity and corrosion resistance. Also, it's not that it has a lower price, so it's very common in houses and etc. And gold is a highly conductive material that is most common used in electronics and aerospace applications. And the properties, the properties of a conductive material is typically that they have a high electrical conductivity and very low resistivity. Then we have insulating materials. Well, insulating materials are substances that resist the flow of electrical current or heat. They are used to prevent the transfer of electricity, heat, or sounds from one area to another. And the examples are ceramic materials like porcelain and aluminium. They have a high electrical resistance and are heat resistant, and they are most common used in electrical insulators such as those found in power lines and in electronic components. Then we have wood, and wood is a natural insulator, both electrically and thermally. It is used in construction for its insulating properties, helping to maintain indoor temperatures and reduce energy costs. And then we have glass. Glass is an excellent insulator against electricity and heat, and it is often used in windows to prevent heat transfer and is an insulative layer in electronic devices, such as iPhone, for example. Well, these ones are the key properties of insulating materials. Electrical resistance. Insulating materials have a high electrical resistance, meaning they do not allow electric current to flow easily through them, and this property is crucial for material used to insulate electrical wires, cables, and components. Then they have thermal resistance. Insulating materials resist to the flow of heat. They have a low thermal conductivity, which means they do not easily transfer heat from one side to the other. And this property is essential for materials used in thermal insulation to maintain desired temperatures in buildings, appliances, and industrial processes, also in houses. For example, the wood is very good at keeping the temperature of indoor in the houses. Then we have the electric strength. The electric strength is the maximum electric field a material can withstand without breaking down and allowing electricity to flow through it. Insulating materials have high dielectric strength, making them suitable for use in capacitors, transformers, and other electrical devices. Then they have mechanical strength. Many insulating materials also have a good mechanical strength, which is important in withstanding physical stresses such as bending, stretching, or compressing. These properties ensure the durability and longevity of the materials in various applications. We have chemical resistance. Some insulating materials are resistant to chemicals, acids, and other corrosive substances. These properties are essential for materials used in harsh environments where exposure to chemicals is a concern, and they need to have this resistance so they can be used without any harm to anything. Then they also are flexible. Insulating materials used in wires and cables need to be flexible to allow bending and installation. Flexibility ensures that the insulator can conform to the shape of the wires without cracking or breaking. This is not a property that all materials have, but for example, plastic does have this property of flexibility. Then water and moisture resistance. Insulating materials for outdoor or wet environments should be resistant to water and moisture. Water can reduce the effectiveness of insulating and lead to electrical hazards. Because water is not an insulating material, so the insulating materials must be water resistant. And to end with the properties, we have lightweight, and especially for applications where weight is a concern, such as in aerospace or automobile industries, insulating materials are often lightweight while still providing effective insulation properties. These properties can vary among different types of insulating materials, and the selection of a particular material depends on the specific requirements of the applications, such as voltage level, temperature ranges, environmental condition, and mechanical stresses.